Alrighty, guys, questions? William. The follow set, okay. Okay, sure. Yeah, that's a good start. Okay. Okay, for you guys' information, so there is all slide section here, just in case you want to look at all the slides. But I would suggest we actually go for the page that we got before. Okay, I can reuse them. Let's just do it again. Give me a moment. Follow set. Definitely important, but let me just go back to where we were. Okay, aha. I think that this one might help. Okay, why don't I get all the pages related to follow set, and then we're actually going to see what we need. Okay, that might be better. Okay, let's do this. Okay. Yes, for sure. I think that maybe I just dive directly into the example. So just to show you how to calculate. Yeah. But of course, if you got specific points you're not too sure in the slides, also let me know. For now, let's focus more on the example. Oh, sorry. That's exactly what I was doing. Forgot to switch. Okay, so for the follow set, okay, why don't we start very quick recap about its formal definition. First of all, you want to know that why the follow set would, remember, before we talk about the follow set, we talk about the first set. And the reason we need a follow set is because somehow the first set wouldn't be able to handle epsilon production effectively. So you might still have backtrack. Okay? So that's why we need a follow set. And let's now start with this formal definition quickly, and then we'll see some idea. Okay, so here you can think about we got the follow set of certain variable. Okay, so this V here is just a variable. It's going to be all the words W, and you can see W is simply just sigma star, which means it contains no variable, just the terminals. Okay, and what's going to be the property of this W? Let's take a look. Let's look at these two. We say that the V, which we want to calculate the follow set of, can somehow take one or more derivation into some x. Okay? And then the star variable over here might take one or more derivation into the x. Okay? So thinking this way. So that means somehow V can be derived into a string. And that string there is actually followed by certain words, and that is defined as the follow of the variable. Okay, but we'll definitely look at an example. So you can see that this guy over here in general is the follow. A member in the follow of the V, right? Maybe look at this formal definition a little bit more once we go over the example. Okay, let's look at some example here. Let's say, for example, if we look at, let's say, expression over here. Okay, expression. What would be the follow of expression? Let's see here. You can see expression, what it can follow will be, for example, closing parenthesis, right? Because basically once you have done expression, what can follow that would be just closing parenthesis. That one's easy, okay? And also, why would that be EOF as well? This will be why EOF should be also included, because you can see expression is produced by just a start variable. And that expression happened to be the last components, right? Happen to be. In that case, what can follow expression will be the same as what can follow just the goal, the start variable, which is always EOF. So when you look at the algorithm for computing the follow set, always you want to start with the follow of the start variable will just be EOF. That's how you start with, and etc. Okay? Why don't we go a little bit more algorithmic, just to get some feel. And of course, I think also feel free to make use of recording in case you don't really get complete answer today. Okay, good. Let's take a look. And there will be, okay, let's not dive into line by line detail over here. But I think the critical point you want to get is like this. There will be certain cases you actually want to compare. Let's say this. If you have in your grammar some production rule, which will be some variable produces, a series of components. Let's say that's a production rule. And then you want to know what's really the follow of, let's say, beta k, right? So let's say, how do you calculate that? You actually got different cases. But you know what? Why don't we look at this one here? I think that'll be easier. Okay, let's look at this one. Let's say we got this production rule. We say A produces beta 1, beta 2, and beta 3. Okay? And we somehow want to calculate the follow of each one of them, each of the components. You can think about what the algorithm will do is to revisit every production rule for every iteration. Whenever we see a production rule, we're going to go backwards, the opposite order of the first. And then when we see beta 3, we're going to collect what's the follow of beta 3. And then go on to see how we can update the follow of beta 2 and how we can update the follow of beta 1, and etc. We keep doing this until we reach a stable point, and we can stop. Okay, let's take a look. If you take a look at this, case number 1, think about each one of them. For each component over here, there are two cases. Either the epsilon is actually in the first of beta 3, or epsilon is not there. Either is in there or not there. Because for every component, you actually got these two cases. So that means you got 2 times 2 times 2. You got 8 different cases to handle. But let's only talk about 2 of them, just to get a feel. Okay? That's kind of the little exercise we did in the class. Why don't we start with this one here? Let's say this. We are assuming that beta 3 here is not nullable. Okay? So here we say beta 3 is not nullable. Also, beta 2 is also not nullable. Okay? And then we want to compute what's going to be the follow of beta 3. Okay? In this case, the last component will always be easy. It would, by definition, will just be the follow of the variable that eventually can be reduced into. Okay? So why don't we start with that? So this one over here would just be the follow of A. Let's say this. Okay? And then let's now talk about beta 2. This one will be interesting. Okay? Intuitively, whatever that can follow beta 2 should be the first of beta 3. Agree? Because beta 3 follows right after beta 2. Okay? So we can definitely put it. Okay? Will be the first of beta 3. That one's for sure. But we want to worry about the case where, in case beta 3, if that happens to be nullable, in that case, this can be epsilon. In that case, beta 2 effectively will become the last components in the production rule. In that case, what should also be included in its follow set, the follow of A? Is it the case here? Not really, because we assume beta 3 is not nullable. Okay? So we're going to say union with the follow of A. So in this case, no, because epsilon is not in the first of beta 3. So William is getting a little bit better? Okay. Let's just do one more. And then for the case number 2, you can try it out. And then if you want to compare answer, just go back to the lecture recording for that. It's also there. Let's do one more. What about beta 1? Beta 1 over here is definitely going to be followed by its next component, its neighbor, which will be the first of beta 2. That one is for sure. And now the question is, in theory, let's say this. So we talk about the follow of beta 1. What can follow? If beta 2 is actually nullable, in that case, the first of beta 3 can also follow beta 1. Also, if beta 3 is also nullable, in that case, the follow of A can also follow beta 1. Right? That's the maximum we can get. Okay, let me write them down. But these two are not really applicable for this case. I'll explain why. It can be union with either the first of also beta 3 and also union with the follow of A. That's the maximum you can get. However, in this case, this is not good. You cannot really reach to beta 3 because beta 2 itself is already the wall. You cannot really break it. This one, because epsilon is not in the first of beta 2, which we assume over here. And also follow A also cannot be the case because you can see these two already blocking, so we cannot really go, right? Because both beta 2 and beta 3 are not nullable. All right. Guys, are we okay with this? A very simple question, let's say, for example, I can put will be, I just give you other cases. Right here, I'm only listing case 1 and case 2. I might give you other cases, in which case I'll just say, okay, now symbolically, tell me what should be the follow of this particular component. And you should really write it down as a proper union. All right? Well, okay. Okay, again, as usual, take silence is okay, right? Guys, please don't be shy. I really appreciate you guys coming. Just shout out if you don't get. Okay, let's now do a little bit more just to go to address William's question as much as possible. Okay, this guy here, don't worry. Oh, you know what, guys? Remember, maybe after this question, I'm going to maybe go over together with you very quickly about all the slides, and then I'll tell you which algorithm I will include in the exam and which one you're supposed to know. Let's do that. Okay, it's also for the benefit for everybody. So this exercise over here also we did in the class. Let's say this. Let's get a big picture. We want to calculate the follow set for the entire grammar. What does it really mean? Given this input grammar, we got 1, 2, 3, 4, 5, 6 variables. So that means ultimately, if you want to calculate the follow set, it's more like a mapping. You want to go for 1, 2, 3, 4, 5, 6. All of them should really have their follow set built out. Okay? So, and we are assuming that the first is already known to us. Because in order to calculate the follow, you can see very often you also need the first as well. So assuming that you know how to calculate first, let's now see how to calculate the follow very quickly, or just get on feel. If you look at if you look at the initialization, let's see here. Okay, if you look at here, so the first line here is saying for every variable, their follow is simply just empty. So you can think about we start with just empty, just for now. Okay, or simply don't put anything in there. Right, it's just empty. And the only thing that we have to add in will be the follow set for the start variable. In this case, this will be the goal. In that case, we're going to say rather than empty set, it's actually going to include EOF. Okay? And then this guy here, last follow and also follow, we kind of use this to reach a fixed point. I'm pretty sure really know what I really mean by fixed point. You're more into math, right? But for the exam, I don't think you should really be bothered too much about a fixed point. Understand it as you keep executing the algorithm iteration until you don't find that you can make any further growth of the map for the follow, and then you stop. Okay. Now for the exam, I'll be realistic. I wouldn't give you something that you have to run 100 iterations. It's not possible. Okay. Okay, and then you can go back to the lecture recording. You can get more insight about the trailer over here. The trailer is really about accumulating. You can think about the trailer that we talk about in the algorithm is really accumulating the different sets over here. But let's just get an example. Okay. And here I simply suggest this particular order. Okay. So let's say we start with maybe the G, the go. Okay. If we start with this. We already know that the goal has the has the follow just EOF by default from the initialization. What else can we say? Let me use maybe blue. Okay, you can see the only variable we have is expression, the last components in the production rule. So that means the follow of expression will be also the follow of the goal. In some way, it's going to inherit that because that's the last components. All right. So I'm also going to put. For expression, also put EOF. This will be after the first iteration, right? So because we were only looking at this particular goal. In the exam, you don't necessarily follow this particular order. Let's say you want to do the goal, followed by factor, followed by expression, followed by term, followed by term prime. You don't need to. But ultimately, you should really reach the same fixed point to get all the contents. Okay? All right, let's go do maybe one or two more. What if we want to go for the iteration where we look at the factor, which will be over here? Okay? So we got 3 production rules. For these two, we can simply say they are not applicable because these two are not variables, so it's nothing for us to really accumulate, right? And only this rule we should look at, this one here, okay? And for this one here, let's be a little bit bigger, okay? Think about what's happening here. This may be something like a beta 1, beta 2, beta 3, but to be more precise, this one here is not even a variable, right? It's just a symbol over there. So that means we only need to consider just the variable components in the production rule. The only one we have is the expression, okay? So now let's look at the expression here. The expression, the follow set, should be the first of what follows that, okay? So here you can think about over here. Think about what's really the first of the closing parenthesis, which will be just itself. That one's easy, okay? And then, because this symbol here is not nullable, we definitely don't have to union the follow of expression by also the follow of factor. We don't have to, right? We are already hitting the wall over here. Okay, let me write it down so you can definitely think a little bit more about this. The follow of expression, not including the follow of the factor, which is over here, because this neighbor over here is not nullable, because this symbol over here is not nullable. Okay, still the only symbol we got to put will be just this one here. So far we have done 2 iterations. We have handled 2 production rules, and we have updated both the goal and also the expression. That's what we have done. You just keep going, until you cannot really grow this anymore. William, would that be okay? Do you want me to go maybe just for one more iteration? Or you kind of get a feel? You're good, okay. Don't worry, please, I think that's pretty much captured the absence. I think, let me recap what you should know about follow set. Number 1, you want to maybe just get some insight about what's really specified here. I would say only look at this after you have done the example and understand the feel, okay? For the algorithm itself, to be honest with you, I'll give you this algorithm, but when you actually calculate the follow set, I would say it's a no-no that you simply just follow line by line to execute. It doesn't work that way. I think I try to follow the way I try to explain to you. You want to go from the end to the front and then look at each one of them to see if I want to calculate the follow of this, for example, I always should get the first of its right neighbor. Should I go any further or not? Depends on whether or not its neighbor is nullable, okay? So for example, let's say if I want to calculate the follow of this, maximum, I may have to go include this one here and this one here, only if both of them are nullable. But it depends. That's why we got 8 cases to really consider, okay? And then, so that's the first 2 iterations for this. But if you want to calculate more, you can also look back to the lecture. Okay. Jingyi, are you okay? Good. Colin, I'm pretty sure you're confident.
Yeah, I have a question.
Go ahead. Other things, sure, no problem. I'll just make sure William's okay. Good, awesome. How about we answer your question first? Yeah, I just got to remind me. At some point, I'm going to talk about what algorithm will be given to you in the exam. But let's answer your question first.
Yeah, so I just wanted if we could do something like on the 3rd quiz where we had to do the epsilon closure and then do the
Oh, you mean to? You mean the third quiz? Was it something about the
Second quiz.
second quiz? Oh, you mean to convert the epsilon NFA into DFA?
Yeah, I just wrote a small example of that.
Oh, you want to do it together?
Yeah, maybe just a small.
Okay, that's something you still, okay, sure. So you're just wondering about how to calculate epsilon closure and etc., right? Sure. Do you happen to have a copy of your quiz number 2? You don't. I don't really have that copy here in this computer here. Chinyi, do you happen to have it? If you don't mind, if you can, I can borrow your copy. Thank you. Yeah, I'm gonna draw right away on the iPad. Okay. Yeah, absolutely. Let's do it. And also, she got perfect score, so I can also use her solution, which is nice. All right. Okay. All right, let's take a look. Okay, you guys can take a very short break for 1 minute. I'm going to reproduce the diagram. And then I would suggest some exercise after going over this that you guys you can try. It will be a very nice one. Okay, epsilon, 0, 1, 0, 1, and then epsilon over here, 1, 1. Okay, let me just make sure I didn't miss anything. Oh, indeed. This one should be 1 here. Yeah, Qin, if you don't mind, I'll keep you a solution here, just in case. Okay, so let's look at the original question. First of all will be the transition table. Why don't we just go over very quickly since you got the question. Okay. First of all, let's start with the transition table for the epsilon NFA. Okay. You want to think about the transition table. Let's start with the transition table, in which case it should include the epsilon. Okay, so here's a critical difference. The input will be the epsilon NFA, in which case its transition table should include epsilon transition. On the other hand, the output will be a DFA, in which case its transition table should not allow any epsilon transition, right? Let's get it clear first. All right, so we got different states. We got Q0, Q1, Q2, Q3. Very, very straightforward. Let me just talk about, for example, epsilon, just for example, okay? If I actually try to go for epsilon from Q0, right? The only one I can end up with will be just Q1. So here has nothing to do with epsilon closure, not yet, just about transition, okay? So the only state will be Q1. And don't forget, the resulting state for each transition for NFA will be just set of states. So that's why you will need to put over here just Q1, okay? Taking epsilon. And also, for example, from Q1, if you take epsilon, it will be Q3. One more. From Q2, if you take epsilon, nothing, right? Empty. From Q3, no epsilon transition defined, empty. I'm sure you can complete the rest, okay? So this one is not too bad. Let's save some time by going over to the next one. The next one is about calculating the epsilon closure, okay? I can tell you that in the quiz, in some way, I was trying to guide you, lead you guys to the ultimate solution, because in order for you to calculate the ultimate, to do lazy evaluation, you definitely need a transition table for the epsilon NFA and also epsilon closure. So that's why I included them. In the exam, if you don't see me asking you these two separate questions, you want to make sure you do that by yourself, okay? Transition table, and then epsilon closure. Okay, let's talk about epsilon closure. For example, what would be the epsilon closure of Q0? And always include itself right away without even thinking. And then you want to see how far can you actually reach. Of course, you can look at the recursive definition that we included in the slides, but I would say if you got a diagram available to you, why don't we just take a look. Q0, by taking epsilon, can just go to Q1. But Q1 there can also take epsilon to Q3. So that means the closure should really include Q0, Q1, and also Q2. Okay? Are we okay? Good. Q0, Q1, oh, and also Q3. What about the epsilon closure of, let's do another one. How about Q1? This one over here would be, of course, Q1 and also Q3. Right? You can see it's itself, and also you can definitely make to Q3. Okay? Like that. Holly, are you okay so far? Okay, so that's good. You can definitely look at others. And the next step is really to do the lazy evaluation. Okay? Why don't we try maybe 1 or 2 rows on the table, and then you can continue. Okay. So far we have done transition table for the input epsilon NFA, and also we have done the epsilon closure. So these two are the necessary preparation, and let's now do the lazy evaluation. Okay. Let's now do the transition table for the output DFA. Okay, the transition table before was the input epsilon NFA. All right. Let's now take a look. So this will be the ultimate output that we want to calculate. All right, this one here. Let's take a look. So let's see how we start with that. And in this case, there will be no epsilon transition. Okay, so the only transition that's now epsilon will be 0 or 1. So we're going to have 0 here and also 1 here. Okay, and then what will be the initial one? Okay, so this one here is going to be, we know the starting state is Q0. Okay, but it's going to be the closure of Q0. It's going to be the E close of Q0. All right, in that way, it's actually going to be Q0, Q1. Okay, Q0, Q1, and also Q3 over here. Okay, like that. You know what? Just to be safe, let's take a quick look of the epsilon closure definition very quickly. Let's go there quickly. Okay, that's the closure here, closure here, closure here. Yeah, epsilon closure. Okay. You can see the epsilon closure of some state Q is going to be the Q itself, of course. And then you want to see, okay, you want to see basically all the other states where you can go from Q using epsilon. And then once you get those states, you want to calculate the epsilon closure as well. But keep going, basically. Okay? Let's now take a look. So that's why this will be Q0, Q1, and Q3. Okay? And then let's see, how do we calculate 0 over here? All right? There will be 2 steps you got to follow. Basically, for every state over here, you're actually going to use the transition function to see what the resulting state is. And then you're going to calculate the epsilon closure for each one of them. Okay? So here, this entry. This one here is going to be, so Q0 taking 0. And then for that one there, you're actually going to get some states. And also delta of Q1, and then taking 0. Union with the delta of Q3, and then 0. All right. Once you get all these states, you're going to calculate the E close of each states. That's what you can compute. Of course, you can look at the solution that I gave to you. Right? That's kind of the steps you got to follow, and then you'll get it. Right? You're going to do this for this entry here, and then do for this entry, and then you want to see the resulting subset states. And then if the resulting subset state doesn't really exist just yet on this column over here, that means it's unexplored. In that case, you're going to put it as a new one, and then you're going to keep going, right? We said this is lazy evaluation because we don't necessarily have to go up to the exponential number of subset state. We don't have to. So whenever we have covered all the subset state in the column, in the left column over here, we are done. Okay? Good. Awesome. And as a promise, there will be one exercise you can try. Just try one. I know I'm pretty sure you got other things to do. Remember for assignment number 1, there was a website where you can actually have some example epsilon NFA, and then it will generate a corresponding DFA, right? Why don't you randomly let it generate one epsilon NFA for you? Apply this technique over here to convert that into DFA, and then compare the answer. That'll be one exercise you can do. Okay? Good. All right, Jingyi, thank you so much. Okay, while you guys are thinking about the question, why don't we very quickly take a look on all the algorithm that you're supposed to know, or something that I will give to you on the exam. Okay, but meanwhile, you can still think about what question you might have. Okay, and meanwhile, I'll take some notes. Okay, let's start with the lexical exercise, right? So here, let's see. Whenever I have some algorithm, I can stop and then give you a very quick recap about what you should know about that particular algorithm. Okay. I think this was the very first algorithm we actually had in the course, right? This is about how you can actually calculate the convert from NFA into DFA. Okay, I would say this one here. Yeah. Okay, so this will be slide 40. Okay, so I'm going to make a notes. Lexical analysis. Slide 40. And this will be the algorithm for NFA to DFA. So this one here, I'll make sure I give it to you, right? Don't memorize. However, for this one here, I don't really think you're going to, let's say if I really ask you to really convert from NFA to DFA, I don't think you just want to execute this line by line to do the conversion. Follow the step that we did in the class. This one just for if you want to code it up in Java or any other programming language. Okay? Okay, I'm also making a notes at the same time. So I'm going to recap at the end. Okay, that'll be slide 40. And then let's see what algorithm. Okay, not here, not here. Okay, we're getting to the end. Okay, minimizing DFA states. Okay, that'll be slide 57. Okay. Okay, that one I'll also give to you. And of course, that is something you may also want to review the example that we cover in the class, right? And for this one here, I want to highlight quickly. You want to always remember what should be the initial partition. Should be accepting states versus non-accepting states. That's how you start with. And then for each step, you're basically looking for some split from the partition. When you get to the point that you cannot split anymore, that'll be the minimum. All right? That's kind of a very quick recap. Now, of course, refer to the lecture if you have any trouble. But this also is the algorithm I'll give to you. Okay, and then this one here is the next word. Okay, slide 62. Next word. And that's the algorithm that you were given for quiz number 2. Actually, but if you need it, I'll definitely give it to you. All right. Oops. Okay. All right. That's about lexical analysis. So far, we talked about 3 algorithms: either the NFA to DFA, minimize DFA, or next word. Okay. And let's go on. Okay. Just summarize all the algorithm. And then I'll definitely take more of your questions if you have any. The next one will be syntactic analysis. Okay, let's see the first one. Okay, so what I should go to, let's go to syntactic analysis. Okay, yeah, let's take a look. Okay, let's see, the first algorithm should be the top-down parsing, I believe. Okay, top-down parsing. For that one there, I can also give it to you. So that will be slide 34. Okay, slide 34. The top-down parse. Okay. However, for that one, yeah, that one there, I would say you may just want to get very familiar about how to do it in general. Okay. And then if I really want to ask very specific line, in that case, I'll definitely refer to the listing, so you can look at the algorithm yourself. Right? Just make sure you're familiar with it. Okay, and then let's now take a look further. Remove LR. Okay, sure. There's no point to really memorize every line. Slide 38. Remove left recursion. Okay. However, for the first over here, you will need to know its definition. Right? Don't memorize it, of course. You should really know how it is supposed to be calculated. Especially, you can see you want to understand for the first of certain component, why there would be two cases. Right? Want to actually look at that. Okay. Right? Get it first. I'll give it to you for sure. Slide 44. Slide 44, that will be get first. And then the one we just look at, slide 49, get follow. Slide 49, get follow. And then that'll be the top-down. Oh, this one here is actually just with the modified version. So that one is OK. I don't need to give it to you. But that one there, you just have to know. The highlight would be we only change the one line by adding a condition, right? To say we want to look at a look ahead symbol. So that one is OK. And then this one here, this one, don't worry. This one just an example. It's not algorithm. OK. And then this one here, yep, I'll definitely give it to you. Bottom-up parsing. That would be slide 61. Okay. Slide 61, bottom-up parsing. If you okay, I can do some very quick recap about how you can review the whole lecture here. We kind of started with this algorithm over here with the assumption that the action and the go-to tables actually exist, right? We try to trace maybe different input string by using the bottom-up parsing algorithm, which is not too bad. It's just about looking up the whether you want to do a shift action or the reduce action. And we also talk about over here about a handle, about a stack, right? That's something you can also review. And then we start talking about the bullet point, the symbol, how to represent the parser states. Right? This notation over here, that's really where things can get a little bit tricky, right? I can also give you guys some exercise you can definitely try to do. Okay, let me just finish going over all the algorithm. Okay, closure. Yes, I can give it to you. For the closure 73, Okay, we're almost there. Bear with me. And the go-to, yes. It's simple enough, but I can also give it to you. 75. Go-to. And then build CC, I believe that might be the second last one. So slide 77. Okay, I believe the final one is here, build a table, right? Slide 82. Slide 82, and I'll just say table here. Okay, I believe that will be it. Yeah, that will be the last topic that we spoke about on Tuesday, right? All right, so that's a summary, right? I'm gonna make this page available to you. I'm not saying that I'm gonna have like a very giant appendix section with all these algorithms, not really. I'll make it easier for you. I will only include those you might need in the exam. For example, if the question is about convert from NFA to DFA, if you really want to record some detail, you can definitely look through the appendix for that. Yeah, I'm just saying that if I ever want you to really answer questions related to this algorithm, I'll make sure it's there. You can just go to the appendix. If it's not there, that means you don't need it. Okay? Okay, so that's something you can definitely take into account. But I would really suggest, let me say some things before you guys can ask me questions. For this and this, as we try to do in the very beginning, if the question is really about given certain production rule, calculate its first and calculate its follow. You don't really want to just trace the algorithm in the appendix. It might be too slow because you only got 3 hours. It's not that many, right? So you definitely want to just really try to solve problem the way we try to solve it in the class and today, right? So let me put a star. Star means you don't need to trace line by line. Almost every one of them. You don't need to. Trace line by line. So definitely not this one here, not this one here. I think the closure and also the go-to. So these two are kind of special. I would say these two are pretty brief, but it can definitely remind you about how things should be done symbolically. So you just have to make sure you're familiar enough with how patterns should be manipulated. That will just remind you. Okay, but anyway. Okay, and also, yeah. Let me see if there's anything else. Yep. I think closure, go to, and also remove left recursion. So these are the things you want to also make sure you understand them well enough. So if you really try to trace the algorithm, you'll be quick in the exam. Okay, good. I think minimize DFA as well. That one there, you also need to make sure you know how to do things. But looking at the algorithm can also remind you about how things can be done. All right? All right, there we go. And final thing, you don't need to really trace this line by line because we know how to do it. All right? All right, more questions, please. And also don't forget, we spoke about composite and visitor, right? Make sure, please study them. I know it's software design, but it's also part of the learning outcomes. We really need to know how to do things the appropriate way. So that means for the composite and visitor, you may also want to review what's really polymorphism and what's really dynamic binding, okay? If you have any doubts about them, you can go back to the, very easy for you to look up. Just go back to the lectures page. Let me show you very quickly. If you go back to the lectures page, and you can potentially go back to maybe the 2030, somewhere in an inheritance lecture, just look for the word polymorphism and dynamic binding. Just quickly review what they really mean, okay? I'm not saying they will be on the exam, but they're part of what can be on the exam. So you want to make sure you don't miss them, just in case, if they appear. Yeah, so the design patterns, the composite, the visitor that we spoke about, and what we spoke about back on Tuesday, let me just mention them one more time, okay? Because that's kind of the last topic we mentioned. So let's talk about them very quickly. Yeah, you want to make sure you understand what's really shift-reduce and what's reduce-reduce conflict, for sure. And then this one here, okay, what you need to know. Given the transition function, either is a DFA or a transition table like this. Oh, I'm so sorry. Thank you. Let me say it again, right? Oh, shift-reduce and reduce-reduce, right? That's what I just said. And this one here, given the transition table either is a DFA or maybe just transition table, okay, transition function. You want to know how you are supposed to fill out the corresponding entry for the shift, the corresponding entry for the reduce, and etc. You don't really want to just study the algorithm from the appendix in the exam. You cannot afford the time, right? Make sure you do enough study beforehand, okay? And also, we talk about if I give you a particular, let's say, if I give you a particular set, canonical, a member in the canonical collection, and then give you some symbol. Remember, a symbol can either be a terminal or non-terminal. And then what should be the corresponding go-to set, right? Make sure you also know how to do it, okay? All right, and then let me see what else. Like how to calculate closure, and then we got to talk about different dimensions, right? Like how you can systematically figure out. Sometimes I wouldn't necessarily simply ask you to really just give the closure precisely. I might just ask you about how many, or what's the cardinality of the closure. Sometimes you may just be able to figure that out systematically without enumerating all the elements like this. You might just be able to, okay? For that part, I can let you review the lecture, okay? Okay, that's about what we spoke about on Tuesday, okay? Yeah, just make sure you can calculate the go-to, whether this is a variable or whether this is like a terminal, and also you're able to fill out the table, right? Like here, all right? Anything else? Do you have any question for you? Not, okay, all right. Qingyi, do you have any question? Oh, how to trace a follow set algorithm? Okay. Let me just go back there. You mean like here, right? Okay. Yeah, so this one here, we didn't really do in class, okay. I would say as long as you know how to calculate the follow set, I think, again, the algorithm for many cases, they are there because in case you're interested in turning them into code, that's what you have to calculate, okay? But the critical thing is you can see, okay, let me try this. Let me try to help you a little bit. If you look at this production rule, let's say I want to, okay, because we know that as soon as we see that we got beta 1, beta 2, and all the way up to beta k. So we may update the follow of beta 1. You know what? Let me say beta k first, beta k minus 1, all the way to beta 2, and then beta 1. Because the way we are going to go for the iteration will be we want to go from right to left. Okay? So it's like this direction over here. Okay? Think about the trailer is really doing this. The trailer is going to get just the follow of A to begin with. Okay? Let's say this. I want to give you a little bit of intuition here. Let's say here, let me simplify that slightly. A would be beta 1 and also beta 2, let's say. Okay? When we say trailer would just be the follow of A, will be just the follow of A. this for sure is actually going to be the follow of beta 2, for sure, right? According to what we said before. You can see here, we can see the follow of beta I, right? This could be the beta 2. It's going to be the follow set of that. Maybe potentially it could be currently empty set or whatever it is. It can just be accumulated by just the trailer. It's going to be accumulated by just the follow of A. You can think of that, okay? And then now we should really get ready for the next iteration, meaning that later on, when we calculate beta 1, its follow set, do we actually have to let the trailer still include the follow of A? We only do that accumulation if the beta 2 is actually nullable. That's exactly what you will see over here. Okay, you can see here, let's see. We say if the beta I, which is the current beta 2 we are looking at, okay, if that one is nullable, that means the trailer has to be accumulated by the first of this. So later on, once we go to the next iteration, the follow of beta 1 is going to get this particular trailer, which will include both the first of beta 2 and the follow of A. Okay, that's basically what the trailer is doing. And we'll keep doing this. On the other hand, if somehow the beta I is not nullable, which means this is not nullable, that means you're hitting the wall right here. In that case, in order to calculate the follow of beta 1, you do not need the follow of A, because beta 2 itself is not nullable, and etc. So that's basically what the algorithm is doing. So if you really want to trace the code, all you want to focus on will be the value of the trailer. Okay. Do you think that kind of helps? I hope. Okay, good. Yeah. But my advice would be, unless I ask you a very specific question about a trailer, in which case you got to look at the algorithm. Otherwise, I would say try to maybe compute the follow set in a way consistent with how I trace the algorithm, which I didn't really look at the code in the class. I think that'll be easier for you. Colin. You mean about different topics, right? Yep, absolutely. So we definitely, I shouldn't say more ways. We will definitely cover stuff about bottom-up parsing. That's kind of the topic which we didn't get a chance to cover by the quizzes, for sure. You definitely want to make sure you study them. Of course, as I mentioned on Tuesday, right? I want to confirm again, just in case you guys are wondering about. The lecture about overview of compilation, for that lecture, you don't need to study, okay? I'm comfortable enough that we don't need to test you that on the exam, okay? Yeah, any concept you think, any concept which I mentioned in the tutorial, you may want to go through that very quickly too, about the antler 4. You may want to. I'm not saying you have to memorize all the code, it's not the case, right? Maybe just think about, maybe give yourself some time to reflect about what's really antler be used for. Is antler itself a compiler? Is antler itself it's a scanner or a parser? Think about those kind of questions, right? I think that's also nice. Let's say once you will talk to other people about, oh, I took a compiler course, I use antler 4. They ask you, oh, what's antler 4, right? You want to be able to explain to them, what is that, right? Yep. Any other questions, guys? We're good? Okay, should I stop the recording?